Hi and welcome to Algebra 1. We're looking at Chapter 1, Section 3, Real Numbers and the Number Line. Square root, let's talk about that. The number a is the square root of another number b. If you square the a, you'll get the number b. So for example, 7 squared equals 49. So 7 is the square root of 49. The principal square root is if the radical symbol indicates a non-negative square root. Now that all sounds a bit weird, doesn't it? But the principal square root of 49 is 7. So the radical symbol is that little funny symbol that looks like a check mark with a line across the top, and the radicand is actually the number that's underneath the symbol. The radicand in our example is 49. So have a look at the next example. Square root of 64 is 8 because 8 times 8 equals 64. The next example, we've got the negative of the square root of 1 over 36. So they're asking for the negative value of whatever 1 over 36 the square root of is. So let's try this. We have the negative answer, and if I have a look at the square root of 1, I can see that that radicand is a perfect square. And if I have a look in the denominator, I also see a perfect square there, and that would be 36. So really this isn't quite as hard as it looks. So I can find the square root of 1, that would be 1, and then the square root of 36 is 6. And remember, we want the negative of this answer, so we have to drag the negative along. Okay, next real life example is a lobster has eyes made of tiny square regions measuring an area of 386 microns squared. So what's the approximate side length? Well, remember the shape of a square. The area of a squared is the side times the side. In other words, it's the side squared. And if we want to find the length of the side, all we need to do is take the square root of the area. And since they've given us the area, we're going to take the square root of 386. So you can see I'm working this here. Now, if I plug that in my calculator, I'll get approximately, and that's what these squiggly little equal signs are, it's going to be approximately 19.6. Now, if we didn't have a calculator or we weren't allowed to use one on the test, then I could estimate that by figuring out some squares, some perfect squares. So let's have a look at 20 squared. I was thinking 20 squared would be good because it's 400. That's really close to 386. It's a little bit higher. So let's have a look and compare it to 19 squared. 19 squared is 361. So even though the 386 is between these two, it's closer to 20 squared. So you could say that the approximate side length is about 20 microns. So why don't you stop the video for a moment and try to see if you can find what's the value of the square root of 30 to the nearest integer. And when you've found it, then start the video again. Okay, so I'm assuming that you stopped the video and that you tried to estimate this without a calculator. So, did you think of a number, a perfect square that was close to 30? The first one I think of is 36. Of course, the square root of 36 is 6. So it's in that region. And then I'm thinking of maybe, I need a lower number, so maybe the square root of 25, which is 5, might be the right answer. So let's see, 30's square root of 30 would be closest to the square root of 5. So the answer to this question is the square root of 30 is approximately 5. Did you get that? I hope so. Alright, next we need to talk about some number groups, and I'd like to talk about 0, because 0 is a kind of a weird duck. It's neither positive nor negative. It's right in the middle of the number line, and it has positives and negatives either side of it, but it's considered neither positive nor negative. So just be aware of that. Now, 0, let me draw it here. is an even number. I know, that's kind of weird, isn't it? But it's an even number. So beware of that when they ask you for odd and even numbers. The next I'd like to talk about is infinity. An infinity looks like an 8 to the side. An infinity is more of an idea than an actual number because you can never actually get there. But if you have a number line, and let's represent this by a number line, positive infinity is on the right and negative infinity is on the left. And it's the hugest, biggest number you could ever think of, and you can never actually get there. So infinity is, I'll tell you, it's a real number. Okay, so let's talk about the different numbers and number groups. N is the symbol for natural. Well, that's natural because N is the letter that starts with natural. W is the letter that starts with whole, and in the video that you saw with the lady, she says that whole numbers start with 0 and go up by 1, 2, 3, 4, and so on. Integers, she said, are the negative components to the whole numbers. Rational is basically anything that can be represented as a fraction. So decimals can be changed, repeating decimals can be changed to fractions. And then irrational numbers, they have, it depends, they have non-repeating decimals, and they are things like pi and the square root of 12, where the radicand is not a perfect square. So rational numbers are very useful to us, but you can represent them on the number line too. And finally, real numbers, everything you see is real. Everything we know of is real. So let's classify some of these numbers. Square root of 121 is really just 11, isn't it? So what number classifications would it go into? Well, it's a counting number, so it's natural. It's a whole number as well, so let's put W for whole. It's also an integer, which is the letter Z. And then it's also rational, but then it's also real. So the square root of 121, even though it looks like it might be irrational, is really N, W, Z, Q, and R. Now let's do the next one. Negative 0.45. That would be the same as negative 45 over 100, which you can then reduce to negative 9 over 20. So this one would be, it's definitely not natural because it's a fraction. It's not whole, it's not an integer because integers don't have fractions or decimals. But it's definitely rational, and it's also real. So all these numbers belong to at least two number groups. Finally, let's look at pi, negative pi, and square root of 12. I put those two together because they are both irrational. They both have non-repeating decimals if they're converted to decimals, and they're also real. So you'll see any number that you get has two number groups, even though the textbook said that it might only have one number group. Always put the R in there for real. Finally, we're going to look at inequality symbols. And if you remember this first one, it means that it is less than. And the way I remember it is, I think, oh, it kind of looks like an L if you turn your head to the side a little bit. It looks like an L. And then the next one is greater than. So I don't know how you're going to remember that, but it doesn't look like an L, does it? So I just remember it that way. The next one over here is less than or equal to. It has the little bar, and that's the equal to part. So if you covered up the top part of that less than, it would look like a sideways equal sign a little bit, or equal to. And then that means that the last symbol must be greater than or equal to. So make sure you know those off by heart because it can be confusing depending on which way they're going. Greater than or equal to. So in your textbook they're going to be asking you to compare things using an inequality sign. For example, square root of 17 and 4 1/3. Well, what you need to do is get out your calculator and plug in the square root of 17, and you'll see that it equals approximately 4.12310. And it depends on how many decimal places that your calculator has, depends on how many little things it'll show you, little numbers, but what we assume is that it keeps going and doesn't repeat at all, so it would be an irrational number. For the next one, 4 1/3, if you put that in your calculator, you'll get 4.33333, and it'll keep repeating. And the way we write that is we write 4.3 and we put a little line over the 3 so that we know it's repeating. Okay, once they're in decimal form, they're really easy to compare. So I see that they both have 4 as their integer value, and then the first decimal place, we're comparing the 1 with the 3. So it looks like that square root of 17 is actually less than the square root of 4 1/3. So now we're going to write that in its original form. So square root of 17 is less than 4 1/3. So put it back in its original form. Okay, for the last example of this video, we're going to compare all these numbers, 1, 2, 3, 4, 5 numbers from least to greatest. So, first thing we're going to do is look at rad 4, square root of 4. Sometimes I say rad, as in short for radical. So, square root of 4 is 2. Square root of 2 over here is approximately 1.4. That's good enough for now. And then 0.4 is the same as 0.4. Negative 2/3 is negative 0.6 repeating. And then negative 1.5 is already in decimal form. Okay, so now we should have a really easy time putting these in order from least to greatest. Now think about where they are on the number line. Negative 1.5 is furthest to the left, so it's actually the smallest number. Okay, the next negative number I see is negative 0.6. Okay, so that was a pretty easy comparison. Okay, the next number, I've got to choose between the 2, the 0.4, and the 1.4. So I'm thinking that the next number on the number line will be 0.4. And then I see that I've got to choose between 1.4 and 2. Well, 1.4 is left of on 2 on the number line. So there's my lineup of the decimals, but remember I've got to put them back in the original form. So it should go negative 1.5, then it should go negative 2/3, then 0.4, then square root of 2, and then the square root of 4. Thanks for listening, and we'll talk to you next time.